Okay, I will be talking about one single element that has several faces, but not only several faces, but also several stories behind, and which basically led to the fact that today we are in preparation of a globally binding instrument which is called Mercury Convention, that is being a subject to be prepared by all of the states on the globe, and then of course ratify that and then implement. So it's a long way to go. But mercury is there for quite a long time, and mercury problems that several countries have are quite numerous, as you are going to see. And what I would like to do, because as I see you are mostly from the law background and some technical experts, I would like to say why mercury is really such an issue. Then I would like to enlighten a little bit this problem of local, regional and global concern, because I already asked a question on transboundary movement of contaminants, and this is something that is really an issue that requires multi-state and regional and global approaches. Then I will talk about mercury polluted sites. I could choose something else, but I think I wanted here to show that the source category and risk, how they are connected on the examples of Minamata, which is in Japan, and Idrija, and the Gulf of Trieste, which is the case study here in Slovenia. And then maybe some lessons to learn and remember when we talk about these kind of problems. So mercury is one of the chemical elements, is a toxic metal. Nowadays we don't use the term heavy metal anymore. In legal language this is still used, but UPAC, which takes care for nomenclature, heavy metal, term heavy should not be basically used anymore. Mercury is a very useful element, and for that reason it has been used for not only for centuries but for more than that. And because of its properties, so it can be used for various products, it can be used in processes, industrial processes. You probably have mercury amalgams in your mouth still, because in Slovenia we do use that. Mercury thermometers, now you cannot buy them anymore, but you still have some with your grandparents, I guess. So this is most common. You know that this is a silvery liquid at room temperature, is also a metal that evaporates. It can be in a vapor form. But the other thing that is really important about the mercury is that it occurs in the environment in different chemical forms, and each of these chemical form is totally different in its behavior, fate, and also effects on ecosystems, including of course humans. And the most important ones are elemental mercury, the one that you see here is this one, which can also evaporate and we can be exposed through inhalation. Then there are inorganic mercury forms, which are mercury 1 plus and 2 plus. Maybe you can remember some of your chemistry lessons from the high school. These are quite useful in many products. But the most important one, and we will see later on, the one that really causes all the problems are organomercury forms, which can be produced by men, which is the case in Minamata, or can be produced from inorganic mercury in the nature, in the presence of certain physicochemical conditions and the presence of contaminants. Now, the first outbreaks by which humans really pay more attention about this toxic effects of mercury happened in 1950, 1960, and this was the Minamata epidemics. I will talk about this a bit later. But also, there were a lot of case studies where people were exposed occupationally because of the production of agrochemicals, use of mercury in medicine and industry. There were a lot of occupational exposures. And due to that fact, there was a number of legislation acts. There were a lot of attention paid to that, and in 1970 and onwards, countries put in the legislation, and then, of course, when this was there, people thought that we solved this problem with mercury, so things are set. And of course, the research, if we look into the relative intensity of research measured by the number of published papers and the money that was used for doing research related to mercury, of course, decreased. And then, of course, at the same time, new technology, especially the development of new and very sensitive analytical tools, enlightened some of the stories which were not known before, and this is that mercury, when it is emitted to the environment, it will stay there for a very long time in the atmosphere and will travel to very far away distances and be deposited to places that are completely pristine, have nothing to do with mercury pollution. And not only that, it is not only mercury, there were many other factors such as acid rain, which also helped that this mercury was deposited in ecosystem sensitive areas where this mercury became methylated, and then it went into the biosphere. And then, of course, when this was discovered, a number of the amount of money spent for research increased a lot, especially in the United States, Canada, and not so much in Europe, though initially this came after the United States started to put out a lot of papers. And then from the 1990 to 2000, there was a kind of a feeling that we know enough to improve the legislation. But there were a number of things there which were related to understanding better the global mercury cycle, mercury behavior in tropics, because mercury is today used by about 18 to 20 million people to extract gold, and this is in most cases the illegal use of mercury. Then Arctics, in Arctics, which is one of the most sensitive ecosystem to mercury load, they found a lot of accumulation of mercury. Then the health issues. One is the issue of occupational exposure. The other issue is when you are exposed over a long period of time to elevated levels that are quite low, but you are exposed for a long period of time. What kind of problems do we have there? About the waste management, remediation, policy, tools, and legislation. This would be something that, of course, you would be most interested. And then US EPA prepared a report to the Congress, which was a 7 volumes report of that kind, and that was really largely discussed. Then UNEP, United Nations Environmental Program, took this on board and recognized this is a real global problem, we have to deal with this problem. Then came a global plan of action, and out of this, of course, is all these initiatives for the global convention that would be legally binding. And then the EU woke up a little bit and started to put a bit more money for mercury research. And to make the story short, of course, the mercury research just took off. This is, for example, just an illustration. In the 1990 in Sweden, there was the first international conference on mercury as a global pollutant, where there were about 100 participants showing the latest results. And then in 2006, there were about 1,100 participants with excellent research presented. And of course, again, shows that the United States puts quite a lot of money into research. And then when it was in China, this was a little bit lower. One thing to remember here, toxicity of mercury depends on mercury form, depends on how people are exposed, whether in inhalation, ingestion, and then, of course, the dose that matters. And the two things to remember here now when we will talk about these two case studies is that we have mostly the exposure to elemental mercury vapor today, which is because of the amalgams that we still have, or maybe in occupation, like dentists that still use this, or in industries where mercury is still used. But the damages caused by elemental mercury that we are exposed to today, all these damages can be reversible. Then we have this down here. We're not going to address this, but the cause also of Minamata disease is monomethyl mercury or methyl mercury compounds, which we are exposed through food consumption, mainly through fish. The damage is irreversible, which means once damaged, you cannot recover. So again, why mercury? It is because this is proven impact on the local scale, regional scale, and global scale. Once you mobilize mercury, which is naturally present, it will circulate, it will be like a ping pong, it will always stay there, and it will take a long time before it stops. It has high toxicity among the so-called toxic metals. It's one of the most toxic. And it is especially because there is a number of vulnerable people and also species in the ecosystem that are particularly very sensitive. And mercury is bioaccumulated and it biomagnifies, and that really is a persistent contaminant such as the POPs that we all know very well. Another thing is that the most sensitive population to mercury exposure are those that are still in the development of central nervous system, which is the target for its negative health impact. And this is women in childbearing age, most of you that you are sitting here in the audience, then the pregnant woman, the lactating women, and then, of course, those that are occupationally exposed, and people that depend heavily on consumption of protein originating from fish. And then, of course, we should not only think in such a selfish way that only the humans in the ecosystem are exposed. Also, we can, for example, learn how to live. We can avoid fish that has high mercury. We can take some precautions, but the wildlife, birds in particular, they don't read, they don't know what the legislation is. So we really have to behave in the proper manner to protect those as well. Just to say that mercury in the environment has been present forever, and it is there specifically in some of the areas in the earth that is rich in mercury. Here we will normally find a lot of mercury. We are quite very lucky that Iceland is not in this zone, because we would have huge emissions of mercury during this volcano these days. So, and in the map below, we can see where are the major sources of anthropogenic mercury emission to the global atmosphere. But what is really, I'm not going to discuss this, I'm just trying to tell you in a very simplified way, what is the current state of the mercury presence in the global atmosphere and what it was in the pre-industrial period. In the pre-industrial period, because of the natural processes, we had about 100,000 tons of mercury evaporating from all the surfaces. And then today, because of all this additional anthropogenic activity which moves mercury from its natural environment, this is more than doubled. And for that reason, we have really much more mercury now in the global atmosphere. Of course, there are certain factors that we can talk about, uncertainties here, but this is quite, uncertainties are on both sides, on the natural and anthropogenic. And then, of course, because of this behavior, which is really the one that causes most of the problem, and this is why mercury is so much different from other metals, because of this chemistry and transformation and transport processes, we have this evaporation of mercury from the surfaces, and this is also doubled. As you can see here is 800, and before it was 400. And because of this behavior, even if we stop all the mercury sources that come from anthropogenic activity, it will take 20 to 30 years before we will see the first signs of decrease of mercury levels in fish, for example. And how is this really illustrated graphically? You can see that mercury will, from a local, regional scales, go into the global atmosphere. And we can measure this. We can see, for example, from China, we have this plume of mercury that goes towards the Arctics, and this is where mercury is mostly deposited. There is this net transfer to the north and deposited in places where there is no local sources. Another very interesting thing, I put this picture here just to make it more interesting for you, because if you look at this is from the ice core, you can see here that there are certain peaks in the ice core which can very well be correlated with certain volcanoes that broke out from regions where mercury is naturally present. So we do have emissions of mercury from natural sources. We cannot say. And Mount St. Helens, for example, you see how really nicely you can see. But there is this story of human impact and increase of mercury on a global scale. And this is due to industrialization. We are measuring now also whether there is any increase of mercury due to Iceland volcano, and the difference is very small. We still are not sure whether this is related to that or not. And what is the best way to understand that there is really a problem is, for example, this concentration of mercury in polar bear fur, which is the very good indicator of mercury exposure through food, shows that in the past levels were relatively low, and in post-industrial era we have much higher concentrations. So it is a worldwide concern, mainly because mercury that is traveling is deposited, methylated, and goes into the food, and then people and other predator species in particular are exposed to this. And it is something that knows no geographic and social boundaries. Now, thing to remember here is that the methyl mercury is the one that is the critical one, and that all the actions that should be taken is really to take care about this one. And most of the legislation in place now, they just say mercury and mercury compounds. They don't even say which compounds. And so everything is about total mercury, and this is what people are regulating now. And this is really a wrong approach completely. Now go to the Minamata city. Minamata is a small fishing, it used to be a small fishing town in the south of Japan, island of Kyushu. A beautiful town where before the industries were put there, people were living exclusively on agriculture and fishing. Then the Chisso Corporation in 1932 put in a production of acetaldehyde, which also required the presence of mercury as a catalyst. And then this corporation was quite an important one, as it brought to Japan about 60% of its income, and owned also 70% of the land of the whole of the Minamata area. And in this industrial process, something happened which they didn't know and nobody knew before, and this is that in the industrial process, inorganic mercury was transformed to methyl mercury in the process of distillation. And they didn't know that. But suddenly, after this production started, some bizarre behavior in animals and humans happened. There are a lot of stories about that. This is just really squeezing out very brief information. So there were some deaths. There were strange effects on animals. Animals start to behave strangely. They were, after all, also dying. And also in humans, there were these the effects on central nervous system, and a lot of newborns that really were born with severe damages. And people thought that this is some virus, some disease that is an indication of poverty, and they didn't even report the problems. They were hiding these problems because they were ashamed. And this is really, this was really, to see these movies is something really crazy. And then this has not happened only in Minamata, but also in Niigata. So Minamata is here at the coastal side, and Niigata is at the river side. It's located in this part of Japan. But in 1956, on experiments that they performed on cats, they realized that Chisso factory is a cause of this, but they still didn't know why, because they knew what the toxic effect of mercury is, but they didn't have any idea that they have methyl mercury present. So the story goes, and finally together with Swedish investigators, they realized that this is the methyl mercury that is causing this problem. And then once the government approved that this is that the Chisso plant is the cause of all these problems, it took about a few years that in 1972 government publicly announces Chisso Corporation part of Minamata epidemics. And that they also realized that they emitted into the environment 30 to 70 tons of methyl mercury. Please remember this number, 30 to 70 tons, because I would like you to compare this with what we have here in Slovenia. And there is about 10,000 people affected, 3,000 died, and today it took them about 30 years before they put things in such an order that people have now compensations for what happened, but I think no money can pay all the suffering that these people had. So Minamata case is a case of acute poisoning because the factory introduced methyl mercury, which was then accumulated in fish, and then people were exposed. What they did, apart from really recognizing and all that they also decided this is now the Minamata Bay, this is very contaminated sediment here, and they decided they are going to take out this sediment, all the sediment that contains more than 25 milligram per kilogram of mercury, and they put it behind in a special place that is completely sealed. And this was very costly, but they did it. And today, this place here that I showed to you is really very beautiful because now this is a recreation area. I put these flowers here from this place because the title of this meeting is Let the Flowers Bloom Again. And here you have the flowers now, and things look like this is settled. I'll tell you what is really not settled, but also more than that. They did something more. They installed a new hospital that works only for the patients of Minamata disease patients, and they also built a new institute. This is the institute, this is International Center, and this is the institute that only performs research on mercury. And it's a beautiful location. They do wonderful things. But not only that, in the city they put together information and education center, which you can see here, that receives annually about 2 million visitors to teach people about mercury story, about industrial pollution and all that. And this was a huge investment, but the problem is still there. If I just want to show you something here, they only, unfortunately, cleaned this part of the bay, but they did not clean the rest of it. And by that, and they didn't have the right criteria to take this sediment. If they have done a better job at that time, they would not face the problem again. Now they still do have a lot of mercury in the bay because contaminated sediment from all this area that was also heavily contaminated is re-entering into the bay, and the fish still contains a lot of mercury. So, anyway, one more thing that happened in Minamata that I think it is very important to mention is that Minamata today is a city of, and is marked as an environmental city. They installed the best systems for recycling of waste. This is really a city that if somebody would like to know how things should really work, you should go there and learn. And today everybody is proud to say, I'm from Minamata. In the past, people were ashamed to say, I am from Minamata. They didn't say where they are from. So now go to Idrija. Idrija is another story. Mercury is there because of natural, the Mother Nature gave us a lot of mercury in Idrija region, and so it started, the second biggest mine, in fact, is located in Idrija, and this is by the amount of mercury extracted from the ore. It operated for 500 years, and about 127 tons of mercury is extracted, which is as a commodity sold all over the world. So we have also this kind of a global problem as well. But about 37,000 tons of mercury were lost into the environment. This is the 37 tons as compared to 30 or 40 to 70, not 1,000, but tons of metal mercury. But you will see that the problem that we have here is much, much smaller than what it was there. So you will see the difference of two different mercury compounds and the problems that this can cause. And today, mercury mine is closed for more than 15 years now, but still, because all this mercury was emitted into the environment, the whole area is quite contaminated. Professor Lobnik already showed some pictures about that, and we know now today with all the modeling tools and all that, that there is about 2,500 kilograms of mercury there in this whole region that still enters into into the river Idrija and Socha, into the water system, and then at the end, when the rivers reach the Gulf of Trieste, we have about 1.5 tons of mercury annually discharged into the Gulf of Trieste. There is another thing which I also already mentioned at the beginning. There is in between also a border. So we have a transboundary movement of this contamination. And of course the Italians would immediately say, well, you cause a problem, you solve the problem. Well, Slovenia, in fact, is not even extracting mercury anymore, but is just facing what has happened before. Now, the mercury mine was owned initially by the Habsburg monarchy and then Austro-Hungarian Empire, where it also presented quite an important source of income to the empire. And then I have to tell you what this really is. We took a sediment core in the Gulf of Trieste, and by measuring the core, you can have the history of how much mercury was deposited, because you can do this because a lot of knowledge about the hydrology and other things in the Gulf of Trieste. So you can see that when we put here the dates, that there is a certain date here, and there is the amount of mercury is increasing, and suddenly decreasing. And the owners were, after you will see here, Italy and then former Yugoslavia. But why I'm showing you this is for another reason. If we go again with this core data, the first, it's not only mercury mine that introduced a lot of mercury in this area. It is the First World War due to the Isonzo front, where there were almost 2 million casualties, I think it was involved, and mercury was used in ammunition. And we can see that this was also when this part belongs to Italy, when really an increased production of mercury took off, but also a lot of mercury that was emitted to the environment is because of the battle that are there. And then what happened in the former Yugoslavia, in fact, was that we stopped mercury reaching from this region to reach the Gulf of Trieste, because we started to put the hydroelectric dams on the Slovenian side, which prevented particles full of mercury to be further traveling down to the Gulf of Trieste. This is quite important because there are recent political debate on the installation of natural gas terminals in the Gulf of Trieste, and there is a lot of debate at the political level at the moment, and this is quite very useful information. So we have this red line, which is identifying mercury traveling, going into the dams. A lot of chemistry, biochemistry goes on with mercury, and finally we have a lot of mercury here. And what is really important is this a problem or this is not a problem? We try to illustrate this with a very simplified figure showing that if we compare population in Idrija and coastal area, and we try to have some assessment of their exposure and compare this with reference doses. This is not reference doses a recommendation. This is not something that is legally binding, because also we are not supposed to smoke, but some people still smoke. And here again you can say to people, this food is contaminated, but people will still decide to eat this food because it is tasty. They take a risk. But as a legislators, I think we have to take care and inform people more about this. What we see is that we do exceed the reference doses that are proposed by the US EPA that was mentioned in earlier presentations, but this exceedance is in a very wide range, and it has to also be experimentally proven. But when we take, for example, FAO WHO recommendation, which is reference doses which are recommended for Europe, we would have much less of these figures here. In other words, much more mercury out, but much less of a problem as compared to Minamata. So these two cannot be compared directly. Plus, the problem that we have here is a long-term exposure to elevated levels. And for this, we don't have even the science-based information how much is too much. And this is still ongoing research. Another thing I wanted to say is that the whole area of Idrija is really a beautiful, pristine area with a lot of wildlife, and not much of the research was being done, but still, based on what has been done, we can see that in Idrija zone, for example, the roe deer receives huge amounts of mercury daily. What that really means or not is still to be done. In the Gulf of Trieste, I'm trying to show you this bioaccumulation of methyl mercury problem. You start with very low concentrations in the sediment, and then this goes as the small fish eat the big fish eat small fish, and so on. The levels can go up that high, and the legislation that can be applied here is that 0.5 milligram per kilogram is allowed to sell the fish on the market. But that's all. Depends on how much of this you eat. It's not, and this is really for marketing purposes rather than really protecting anybody. And I will skip this. Just I wanted to tell you that there were some calculations done for remediation of the most contaminated sites in Idrija, so to take away the most important sources. And these are located here, and the modeling tools were chosen and all that. And it was calculated that if we want to reduce from 2,500 per kilogram per year that would enter the river to about 1,400, that would be a 42% reduction. That would cost 28 million euro. Now the question is this population there really can manage this problem with some kind of advisory and use this for other type of development of the area or not? So here are the questions which I think it's not easy to answer. So what we have learned here. Sites such as Minamata and Idrija are numerous. Here is just, this is just locations that you will find, and you will find them in most cases where mercury is naturally present, because humans extracted mercury and cause a lot of contamination, you can see. And then, now that these sites are there, one would ask, do we really need to do something about these sites? How much this contributes to global mercury budget as compared to, let's say, stationary coal combustion sources? And what we see is that if we sum the atmosphere, emission to the atmosphere and hydrosphere, this will be in the range of about 100 to 270 tons per year. But summing up all together on the whole of the globe, which compares to what happened in Idrija, is quite very small, right? And we still can live. So the question is, how much and what do we have to do with that? Now, just to finalize, is please remember that we have to, now this was a case study on mercury, but there are stories for the contaminants that we have in our environment are similar, not always as illustrative as this one where there is a lot of science-based evidence. There are a lot of places, a lot of contaminants for which we do not have this information, and I think just fixing one value and having this to behave, I think this is not the right thing. So science-based policy making or whatever wish there is, I think this is something that requires interdisciplinary approach, good thinking, and putting together all the resources, and then the investments can be really wisely used for the best. And here I will skip this. Drivers, pressures and all that. Ah, you will like, because I am using too much time. Okay, and then if I want just to go back to this. That's good. One of the conceptual approach for what I have just said, that we really need to have an interdisciplinary approach, and Professor Lobnik will know this very well because I think he was part of the working group at the OECD that really promoted this approach. And I think this approach is really important because it puts together all the phases of a problem and try to make a solution in the best possible way, so that we are not always excusing ourselves, oh, we have no money to solve this problem. So on the drivers, pressure, states and impacts, this is what I say, the engineers and the researchers and people of that kind, these profiles, they have really developed a lot of knowledge. There is a lot of evidence. There is really a lot to take in hands and do to interpret. And so this part is somehow there. But how this part is really connected with the policy response, where we would like, of course, whatever we do here will have all the again have to be re-evaluated. This is still something that needs more work, where more expertise is needed, and I think this is not enough to have people that are experts on these issues. We really need to have more of other profiles involved in order to really have wise management decisions. And I wonder whether now looking into the EU legislation and the ways things go with all the strategies and directives, and it takes a lot of time, is the right approach. But is it maybe too slow? But sometimes we have to make a decision. So what I think is just that we have to work more together and try to make better decisions when we deal with environmental issues in general. And this is how our system of Reka Idrija, River Idrija in Soča looks like. It's a beautiful place, not very heavily inhabited by humans, but it's really a paradise for biodiversity. And we have to think about that as well when we talk about environmental case studies.